Hello and welcome to this PV Magazine webinar. My name is Mark Hutchins and it's great to have you with us on this sunny afternoon here in Berlin. Co-hosting this webinar with me today is Matthew Linus. Matthew, what do we have coming up this afternoon?
Well, it's great to be here today as we're joined by our webinar partner GoodWe, and we're going to take a look at the market trends for C&I energy storage in the first section of the webinar. And then we're going to move on to another sort of engaging part of the C&I sector, which is all things building integrated PV. So we have quite a lot to get through today with all of our guests.
Yes, and we do have plenty of guests coming up over the next hour and a half. We will be joined by Faisal Bukhachuk, Thanasis Sakas, and Barbara Terani, all from GoodWe. And we also have Eric Wallner from Swedish EMS provider CheckWhat, and Tadej Smogavec from Enertech, joining us from Slovenia. Apologies to all of you for butchering the pronunciation of your names there. Thanks for joining us, though.
Thank you for having us.
Thank you. Yeah, okay. There's quite a lot of you there, guys, so we'll talk to you all individually later. Before we dive into the presentations, just some housekeeping for people joining PV Magazine webinar today. If it's not your first time, you'll be well familiar with this, but if you are new, first things first, please feel free to send in any questions you have throughout the webinar. This is very much an interactive session, and we want to get as many questions in from our audience as we can. If you do experience any tech problems, then you can just let us know, first of all, in the chat box in the questions section of this big marker platform. Then our competent behind-the-scenes team can help you out. One quick tip, if something does happen to go wrong, I find that simply refreshing the browser fixes most problems. And lastly, if you do miss anything, don't worry. We will be sharing slides today after the webinar. And now Mark, I believe, is going to take it away from here.
Thanks, Matthew. And yes, and speaking of questions, just before we welcome the GoodWe team and kick off today's presentations, as Matthew said, this is a live interactive session. And to start that off, we have one question right now for you, our audience, that should be popping up on your screen right now. That question is, what do you consider the most critical factor when selecting an industrial energy storage system? And your options are system efficiency and round-trip losses, cooling technology, air or liquids, scalability and modularity, or finally, total cost of ownership. Well, we'll give the audience a moment or two to let those in. Thanasis, what do you expect? What would you expect to see from this question?
I think this is very challenging page that we give now to our audience. I think the CNI storage, it's something, I would say it's a game changer in the market. And it has to be always combination with a low cost, efficiency, and sustainability. And let's see what our friends, they will say here.
Sure. Well, yeah, thanks very much to our audience for getting your answers in. And, well, a bit of variety there, but a pretty clear win for total cost of ownership there. Does that fit with kind of your expectation of what you hear from your customers?
It's a very interesting topic. If we had this discussion 2 years ago, we will have to discuss other topics. But today we see that the trade of the market in terms of pricing, it's extremely expensive in a nice way for the users, for the end users. I think we are talking about a new revolution. We see photovoltaics together with the storage as one piece and in a very extremely competitive, financially speaking way. And this is something that the market already see it, already smell it, that there is a big changes there. I mean, it's easy today, at least it is not like as it used to be in the past. It's much easier today to get the storage system for your house, for your industry, for your application. And we just need to face it in a nice way.
And we also have, quite significant numbers saying, well, either system efficiency and round trip losses, or indeed scalability and modularity are their biggest concern. How do you see those issues? Do you see kind of bigger scaling up to bigger systems and people worried about efficiency?
I think each size has a specific role in our industry. We need to have variety to cover all the needs, because what we see today in the CNI sector, in the CNI storage sector, but it's also the same for the residential storage sector. You cannot really have a copy-paste system. Everyone has his own needs, his own specification, and we can be ready. We have to be ready to supply small, mid, or big size systems, because every of our customers has a very specific needs. So coming back to your questions, I don't think we can focus in a specific size, because everything is a completely special for us. Every single request. We just need to be ready to cover all the needs, and we are ready to do it.
Okay, well, that's a great, clear message to start off with, and well, yeah, thanks, Thanasis, for your insights there on our first poll question, and I believe you have a presentation for us as well, so please, over to you.
Thank you very much. I have a presentation that for my company is more focused, let's say, in the general topic of the CNI storage. And then my colleague Faisal, who is also here today with us, he will be more focused in the technical point. Let me give you a few words about our company. GoodWe it's a global player. It's a company that has our headquarters in China, in Suzhou, and in Europe, our HQ are located in Munich, in Germany. We have 5,000 employees in total, which is not something special. You can find other companies with 5,000 employees, but I think here it's very important, and this is the reason why we pop up these slides. 1,000 of our employees belong to the R&D team. Frankly speaking, 20% of the company is focusing to the innovation, and this is why always GoodWe is one step ahead from the market needs, because we have people that they really love what they are doing, that they focus in the next product. This photo, it's just a simple message to you. Guys, we wait for you in Intersolar in 1 month and a half in Munich. We will be there to show you, to meet you, and to show you all our new products. We are present all over the world, and this is very important topic for a supplier, because whatever comes as a challenge, as a request, as a topic in one country, immediately we find a solution, and this solution is ready for all the countries. Here I would like to use the example of zero feed-in. We had a request in Spain some years ago for a zero feed-in feature in our inverters, and we sorted out for Spain, but immediately when the other regions they requested the same features, we were ready. So global presence means better service for our customers. GoodWe has a huge product portfolio. We start from a very small single-phase inverter of 0.7 kilowatt, and we go up to 350 kilowatt utility scale inverters. We have batteries, we have all the storage systems, we have three-phase, single-phase, EV chargers, heat pumps, building integrated solar modules. Why I say this? I think it's very important to have a partner who can cover you no matter where your market will go. It's important that our friends, they can work with us, they can invest in our name, because we will be always next to them, no matter what the decision for each market will be. Today, we will focus in the commercial and industrial inverter. This is how we say CNI storage inverters. When we say CNI storage, there is a definition behind this. We have usually, let me say, three categories. We have from 20 to 50 kilowatt hours as a small commercial, we call it. We have from 50 to 500 kilowatt hours. This is the medium commercial. And we have above 500 up to 1 megawatt hour, which is the large commercial application, as we say. Of course, you can see outside in the market big storage systems like 10, 20, 30 megawatt hours, but this sector is considered as a utility storage. So today we will focus in the CNI storage from 20 to 1 megawatt hour application. There are benefits and challenges. The benefits are clear from the today perspective. We have lower energy cost. We improve our energy security. We reduce the CO2 footprint for our business, which is sometimes extremely important. There are challenges as well. Until today, we had the problem of the high system cost, high complexity, and lack of incentives. For the first topic, for the first challenge, high system cost, we will see a revolution sooner or later. It's there, it's coming. High complexity, this is something that it will not change. Of course, as a company, we always try to make compact solutions to be plug and play, but in CNI storage, we need also installers and EPC that they are capable to go an extra step. It's not just like we used to have today, the grid connected inverter module, and that's it. CNI, it's a more sophisticated topic, and we need to invest more to the education of the people prior to any installation. No matter what the challenges are until today, we see a growth which is huge. We see a 44% growth. Let's start from 2020. It's amazing, really, a sector which in the previous year, the prices, they were not super competitive in general, I mean. And also the education of the people is not so high to see such a big growth. Imagine what is going to happen when the price of the system will be reduced, when the people will be more familiar with this idea, and when the installers and the EPC companies, they will be ready to proceed. So the expectation for the 2030 are saying that at least the growth will stay 44%. And this is a great number for all of us in this discussion to invest in this sector. And by the way, you saw that Europe still is a major player for these CNI installations until today. Of course, for some people, CNI storage was a niche, let's say, market. Niche market means self-consumption, bill saving, and sustainability. But we are moving now, and we see that we have also great services we can get from CNI storage. We can have market participation from the owners of the CNI storage. And also we see big saving by just simple using a CNI storage application. And let me go a little bit more in details. Self-use. The most beautiful thing is to use your own electricity for your own business. But by using a storage system, you have also less dependence from the grid. So self-use means I manage to use the electricity that I produce, and if there is no sun or if there is whatever problem, I can use the battery, the storage to fulfill the needs for my industry. A very important and completely new idea here is the energy arbitrage that we see it more and more. And this is a completely new concept in the market. You have your own business, no matter what you produce under this building, but at the end of the day, you can play also with the arbitrage. You can make money out of this. We take advantages of the energy prices from the grid to charge and discharge the batteries in a different hours during the day. Is it cheap, the electricity? We charge our batteries. Is it expensive, the electricity? We inject energy in the grid. Another benefit for our CNI storage solution is the peak saving. In this way, the company does not have to increase the peak power contracted with the energy company in order to be able to support the limited peaks. The power contracted can be limited to a certain level and having the battery supporting the peak, reducing in this way the energy bill. So it's not that you have safety, self-use, you can play in the energy arbitrage, but also you can save real money by reducing the contracted power with the supplier. Backup solution. This is a real game changer. We are living in Europe. Some of us were moving outside of Europe, and we know very well what's going on with the weather and the weather conditions. I'm not going to discuss about other force majeure situation. I just need to focus in the weather situation. We see every day how many houses and buildings and industry they stay out of electricity because of the bad weather, because of a typhoon, because of cases like this. CNI storage, I said before, it's a game changer because we bring in the market a backup solution. You are connected with the grid, you have your own system, you can benefit with what we discussed so far, but there is always a better solution in case of a shortcut. You can always serve your building, even if outside there is no electricity in the grid. And this is a safety as well. Microgrid solution. This solution is very much focused in the insulated grids where outages are very frequent. And with this solution, you can mainly work with the off-grid rather the traditional way on-grid, and if there is a problem off-grid. Again, you are connected with the grid, but you can play without the grid and to be on the safe side. Another use case is the frequency regulation, and especially very much focused in the northern countries in Europe. In this case, in case of frequency fluctuation, the storage system can support the grid by either injecting energy or storing energy, so we can help the grid to maintain a frequency always close to the 50 hertz. And what is the benefit for the owner of the system? He makes money because he can compensate, he can be compensated economically from the grid owner just because we support with this way to have a stable frequency around 50 hertz. So this is a completely new story that again gives an extra benefit to owner of the CNI system. I'm about to finish. This is my last slide. You see that either we are talking for residential or CNI storage. Of course, there is benefit and there is challenges. But at the end of the day, the market drives us there. I would like to share with you our experience as a company. 2 years ago, the total installation we're doing the total delivery of our systems, they were 80% grid connected and 20% hybrid, and storage. Today's days, this has changed completely. And this is why I said that we are talking about a revolution, because I can say easily 80% of our projects all over Europe, it's storage project, either residential and CNI, but storage. And this is something completely new with great benefits. And the more we see the price of the system to be reduced, the more trade of the more installation of these storage systems we will see in our market. That was my last slide. I can speak hours for the CNI storage, but our colleagues from BIPV Magazine, they gave me only 15 minutes. So thank you very much for this. And that was a great opportunity for us to share with you what CNI storage means. And you see our passion about this.
No, thank you very much, Thanasis. That was excellent. I think that's given our audience a good jumping off point for CNI storage. I think I'm correct in saying at this point, GoodWe has a video as well that we can share on the CNI
It's
market.
a more technical video, and after this video, Faisal, my colleague, will continue.
Yeah, perfect. Thank you.
Thank you. Thank you very much.
Welcome to GoodWe Training Series. Today we will take you through the ESA Series 125 kilowatts 261 kilowatt hours unboxing and installation. Introduction of the ESA Series. This is the main body of the ESA Series 125 kilowatts 261 kilowatt hour energy storage system. On the front are the indicator light, emergency stop button, door lock and ground port. Energy storage system nameplate and 4G or Wi-Fi antenna connector on the side. Pressure relief valves and water fire connections on the back side. Open the door to energy storage systems. We can see a number of modules. They are battery system, power distribution unit, liquid-cooled units, energy storage converter, local control module, perfluorohexanone fire extinguishing equipment, smoke detectors, temperature detectors. Fire protection system can provide protection against thermal runaway of electric cells. At the same time, the back of the energy storage system is equipped with a standard water fire connection. Here's where the main components are located. Installation of the ESA series. Installation of 4G or Wi-Fi antenna. Open the door to energy storage systems. Ensure that the internal and external ground connections of the energy storage system are secure. Install the AC side cables in sequence. Fasten the cover. To power on the battery, turn the emergency stop switch to the right. Turn on AC molded case circuit breakers in sequence. DC circuit breaker. AC auxiliary switch. DC auxiliary switch. The storage converter starts to operate. Close the front door. After the front door indicator light changes from white to green. Grid connection of the system is completed. This is the unboxing and introduction of the GoodWe ESA Series 125 kilowatts 261 kilowatt hour energy storage system.
All right. Well, we have obviously learned a little bit there about the installation process for GoodWe's CNI solution, but we are now going to be joined to hear a lot more about it by GoodWe product manager for CNI in Europe, Faisal Bukasru. Faisal, I believe I have destroyed your surname there, but thank you very much for joining us. Before we get to your presentation, I think it would be a good idea to, again, ask our audience at home or in the office to weigh in with their thoughts. I believe we have another poll. Those who are watching your video will probably know what the GoodWe answer is to this question, but I'm wondering which cooling technologies our audience thinks provides the best balance of performance and cost for industrial battery storage. Your options there, if you scroll down, you have air cooling, liquid cooling, a hybrid approach, and if you're not sure, let us know. I'm sure Faisal will hopefully try and make the case for why you should be sure. But let's wait and see. While the answer's given there, Faisal, it's liquid cooling for you guys, right?
Well, this is the question we wanted to understand beforehand. Let's see what our audience is expecting or is thinking, and give us a sense on where the market is moving and where they are standing. So I'm not gonna make a spoil in here to check a little bit what are the answers, and through the presentation, probably everyone will have a clearer idea on why we are asking this and reflect about their own opinion and their own.
Yeah, sure. Well, I mean, as you can see here, I don't know if you can also have a look at the polling results here. About a third, or exactly a third, backing a hybrid approach there. Liquid cooling, about 27%. Air cooling, 14%. And around a quarter of our audience, quite honest, they're not sure and interested in learning more. And I guess that's a perfect jumping off point for yourself then, right? Hopefully that not sure number can come down by the end of your presentation.
Sure, thank you. Well, thanks very much, everyone, for being with us this afternoon. And this second part, I'll briefly discuss the new trends in energy storage system for CNI, and especially regarding cells types and the cooling system used for different application sizes. Some of you might be wondering why we played the video about this battery that pretty much nobody knew about. But this is what we're going to be launching in a month and a half in Intersolar. And this is a video. It was intended to be a teaser, although I will go a little bit more in detail through it in a while. But just in case someone is joining us who is new to this industry, I would like to go over some very basic concepts, although my colleague Thanasis has already touched ground. So basically, CNI energy storage system are energy solution designed specifically for commercial and industrial facilities and uses. So basically, this system typically consists of an inverter or a series of inverters, a battery storage units, or multiple units in parallel. Important, a battery management system, although known as a BMS, an energy management system, also known as EMS, to manage the energy flows from generation to storage and consumption, also referred to as load in general. So this management needs to be efficient, both from the energy and an economic perspective. So this system generally stores excess electricity during low demand period and release it during peak times, or when electricity prices are high, reducing therefore the energy cost and ensuring a stable power supply. Now that we have kind of defined what CNI energy storage system are, I think it's important to explore the functionality and the benefits and how they optimize the energy use, enhance reliability, and also contribute to cost saving for a CNI application. My colleague have touched ground, but I would like to point out some things as well. So some key benefits of energy storage system are the optimization and bill reduction. This is what we have been seeing until now, and which are intrinsically related. So peak shaving, value filling are key to achieving this purpose. So that in this function, the energy storage system can shift electricity demand from peak period to lower cost off-peak hours and reducing the electricity bill. So this is interesting in application where they have this flexibility in terms of operation or production line. Another key function that Thanasis has already mentioned is the backup power. So the energy storage system provides backup power during grid outages, and it's ensuring interrupted operation of critical business function. And therefore, we are providing energy security. And here is an important concept to take into account, the energy security. And of course, the energy system, energy storage system helps the integration of renewable energy. This can be a residential, CNI, or utility sector. In here, as mentioned by Thanasis, they are critical for grid stabilization, as they can participate in grid load balancing, frequency regulation, and therefore enhancing the overall grid stability. So companies that uses the energy storage system can choose, depends on where they are and if there is market in their country, to participate in these services and enabling also for revenue stacking and ensuring a fast return of investment. And finally, the energy storage system, they play a key role in reducing carbon emission, reducing reliance on fossil fuel power, and supporting also the sustainability of business practices and demonstrated corporate responsibility and resilience. So when selecting the right energy storage system, there are multiple factors the companies need to consider, including technological features, capacity requirement, economic benefits for sure. So this slide shows some key decision-making factors. First one, we need to identify our energy need and application scenario. This is the basic thing to start with. So if the primary goal is to reduce electricity costs, storage units, systems capacity and efficiency will directly influence the economic benefits. Typically, systems in the range of 50 to 500 kilowatt hour range are very suitable for businesses with significant electricity price fluctuation. So it does help them perform peak shaving and load balancing. And for critical infrastructure, also the storage system capacity should be around 1.5 to 2 times the company's electricity demand to ensure continued operation during outages. For sure, this is to be considered in a case-by-case scenario due to the criticality of the business itself. And for sure, the renewable energy integration, this is a key factor that we have mentioned already. The second point to consider here is the need to think on the battery type and the electrical performance. So safety first. Although LFP batteries have a higher safety rating, it's still essential for businesses to choose systems for providers with an efficient BMS to avoid overcharging, avoid discharging, over-discharging, and other risks related. And for sure, the energy density and space requirement is another factor to take into account while selecting our energy storage system. So lithium battery compared to other battery types offer higher energy density. So it makes them basically suitable for space-constrained C&I environment. And again, it's important to select reliable suppliers. Return of investment is one of the most critical factors businesses consider when evaluating storage system. So return of investment basically indicates the time it will take for savings of energy cost, operational efficiency, and improvement to cover the initial investment. So this return of investment for storage system in C&I is between 5 to 10 years, but it varies depending on the size of the system, the user's environment, electricity price, fluctuation, policy support, etc. So this is another case-by-case thing to be considered. The policy support and subsidy is crucial in here. So many countries and regions, as you all know, provide fiscal incentives, tax rebates, direct subsidies for energy storage systems. So understanding local policy environment is, in terms of subsidy schemes, is crucial for making a cost-effective investment decision. And last but not least is the scalability and flexibility that was also mentioned in the first point. So as business electricity needs might change over time, it's essential to choose a storage system that offers modular design and flexibility and scalability. So in this way, modular system allow businesses to gradually increase their storage capacity without making a large upfront investment. You might have seen that in the first picture, the numbers vary from the one my colleague Thanasis have shown. So we have done this in purpose. And why? Because this is going to depend on every country and every business. So he was mentioning from 0 to 50, 550 to 500 as medium and above 100 as a large one. But in purpose, we changed this number just to, again, emphasize that this is to be seen in a case-by-case and a country-by-country or area-by area. So basically, with the growing demand in the market, the lithium-ion batteries have become the most common technology for the C&I storage. They offer high energy density, long span, high charge-discharge efficiency, and low maintenance costs, making them really the preferred choice for most market applications. So when selecting an energy storage system, businesses typically choose products based on their power requirements and space constraint. So first table gives an idea on these typical project scales based on different capacity ranges, although this depends again on the different markets and also its maturity, which is really important. So systems in the 100 kilowatt hour and below range are typically used for small commercial applications. And they typically offer high discharge efficiency, a long lifespan. So they do help businesses optimize the electricity use and reduce the peak demand charges. And the ESS energy storage system in the 200, 400 kilowatt hour range are typically suited for medium-sized commercial C&I applications. So this system offers a balanced performance, really, providing they do provide a significant storage capacity for sure, but they remain compact and efficient, and they are ideal for application where they need to support demand response and grid regulation, for example. And for sure, energy storage system above 1 megawatt hour, as we see them right now, are more focused on grid level application. And they do provide for sure capacity and scalability. And what I would like to show with the second slide in here, the energy storage system are made up of combination of battery cells, forming basically what we call the battery pack. And as we grow in power and capacity need, different kind of cells are being used in the industry. So for small system cells in the range of 100 amps hour are used really for this sort of application needs large capacity and power requirement. And the 280 amp and 314 capacity are used mainly for large applications and grid support. And I would like to deep dive a little bit more in here. So the C&I industry uses mainly two different kinds of cells, which are we call the prismatic and the cylindrical ones, as shown in the pictures above. The prismatic cells is a cell whose chemistry is enclosed in a rigid casing. Normally, it's a rectangular shape that allows efficiency stacking multiple units in a battery module. So they are mainly used in energy storage system and electrical vehicles. So they are large in size, and they make them really bad candidates for small devices, like, for example, the e-bikes or cell phone. So they are more focused for energy storage solution, batteries, as we call them, like, for example, for residential or C&I. While the cylindrical cells, in here, the cells is really closed in a rigid cylinder can, as shown on the right of the picture. So the cylinder cells are small, round, and they make them quite possible to stack them in devices of different sizes. Unlike the previous one, it does prevail from swelling and undesired phenomenon in batteries where gases accumulate in the casing. This is very important difference between prismatic and cylindrical. And cylindrical first, they were used in the laptops, which contain between 3 and 9 cells, for example. And they gained the popularity when basically Tesla used them in the first electric vehicle, which used about 9,000 cells. So you can imagine the size of it. So basically, prismatic cells are larger than cylindrical cells, contain more energy per cell. And to give you an idea of the difference, is a single prismatic cells can contain the same amount of energy as 100 cylindrical cells. So the smaller size of these cylindrical cells mean they can be used for applications that require less power. While cylindrical cells might store less energy than prismatic cells, they are more powerful. This means that they can discharge the energy faster than the prismatic cells. And the reason is that they have more connections per amp hour, basically, as seen on the picture on the right. So as a key takeaway here, prismatic cells offer opportunity really to drive down the cost by diminishing the number of manufacturing steps, as I mentioned earlier for the cylindrical one. Their format make it possible to manufacture really large scales, which reduce the number of electrical connection that make it cleaned and welded. So basically, prismatic batteries are also the ideal format for the LFP chemistry. a mix of basically materials that are cheaper and more accessible. Unlike other chemistries, LFP do not require rare, expensive materials like, for example, nickel, cobalt, that drive the cost of all the cells high. Here, what I would like to show is some key advantages and disadvantages of every cell type. I'm not going to go in detail in here, but I would like to address the thermal management of each one, since they are the key differentiators really for medium and large scale storage system. So while prismatic cells are better suited for high capacity scenario, the temperature management is key due to basically the limited space between the cells due to their form factor. So a poor thermal management of this battery can really cause a faster degradation of the cells and either fire or explosions. So in the CNR energy storage system, battery cells normally are designed with the varying capacities to make different or specific energy and power requirements. So normally a serial and parallel configuration of the cells are used to achieve the desired capacity as well as operational current and voltage needed. This is what I'm showing in the first picture, which is the SP configuration. But recent development have focused on increasing the capacity of the cells to enhance the energy density and overall system efficiency. So for large CNI, cylindrical cells are used in the 16 serial and 1 parallel configuration, or in the 52 serials and 1 parallel configuration to be able to achieve large capacities. And depending on the cell capacity used and its serial configuration, we can achieve different energy storage capacity and power, as shown in the second infographic. So as we grow in capacity and power, and as explained earlier, the thermal management is key for this kind of system. So the industry is adopting the following barrier. This is as a reference for the cooling system, using air cooling ones for capacities below 233 kilowatt hour and liquid cooling for capacities above 241 kilowatt hour. Although this, of course, depends on the manufacturer, but this is a key reference. And this point might answer to one of the questions of the poll, if it should be air-cooled, liquid-cooled, or a hybrid one. So basically, as air cooling involves using air, basically generated and installed by fans to dissipate the heat and maintain the battery temperature within the battery system. So this cooling system is a relatively straightforward in design and doesn't really require complex infrastructure, which makes it system easy and to maintain. And that's why the air cooling system is much cheaper to install within the energy storage system compared to liquid cooling. However, it has its limitation, which comes to cooling larger energy storage system batteries, containers, which with high energy capacity due to the relatively low thermal conductivity of the air, which is the key concept here. So therefore, air cooling is best suited for application is in low ambient temperature with low heat dissipation requirements. And in contrast, a liquid cooling system uses a circulating liquid to cool the cells. It involves, of course, circulating liquid cooling through the network of pipes to absorb and transfer the heat away from the batteries. So liquid cooling is highly effective at dissipating high-level heat and offer precise temperature control. However, of course, it's more complex system, require regular maintenance, and a higher initial investment compared to air cooling system. And this is where we would like to introduce you to our new batteries that we showed the video earlier. It's a AC coupled system, 125 kilowatts in power, 261 kilowatt hour in capacity. To mention here, important drawn here about 314 amp. I was speaking about 100 amp hour, 180, 200, but you see for this batteries in here, we are using larger cells, which means cylindrical ones. And of course, in here, what we are using is intelligent force air cooling system for the PCS, But for the battery, the modules, what we use is air-cooled. This is a snapshot of what's inside the battery. On the rear side, we have a pressure relief, a firefighting water interface. In the rear door, we have a cooling fan. This is for the PCS, the power electronic side. In terms of fire extinguishing system and security, we have aerosol in here, smoke detector, temperature sensor, and dehumidifier as well. Also the battery packs, and finally the liquid cooling pipes and the liquid cooling unit, which hosted the fluid, the filters, etc. And just as a snapshot as well, just to let you know that in this first step, we're going to release the battery able to parallel up to 5 systems. So we'll be talking about 600 kilowatt in power and about 1 megawatt hour in capacity. But in the second phase, we'll be able to parallel up to 10 and work on grid and off grid. And this is important factor to mention as well, will be coupled with the grid tied inverter. And finally, from myself, I'm gonna kind of repeat what my colleague Thanasis said, but to work with an environment, an EMS is needed. This is a key factor we would like to launch as well today, and most of you already know. So until recently, the EMS was used for self-consumption and peak shaving, which is okay, but new business models for grid services arises, so more developed and complex EMS are needed. And it's in here where we are collaborating with the key partners, key companies that we have invited today. And one of them is CheckWhat. And I pass the floor to Mark from CheckWhat. And thanks everyone for being here with us today.
Thank you very much, Faisal. That was really great. Detailed analysis there of the solution. But absolutely, we now are joined by Eric Wallner from CheckWhat, who can tell us a bit more on the kind of practical application side of C&I storage. I'm here to discuss the Swedish company's collaboration with GoodWe. So first of all, hello, Eric.
Hello.
For those attending who don't know much about CheckWhat, maybe not super familiar with the Swedish market, could you tell us a bit about what you guys offer, what you do?
Yeah, absolutely. I think we should have a presentation, but yeah, it'll probably arrive soon. There,
there it is.
Yeah. So CheckWhat is a Sweden-based EMS provider with the purpose to increase the value of flexible assets, mainly batteries for the customers. And at the moment, we control and optimize around 10,000 battery assets in the Nordics, and I think around 2,000 of those are GoodWe inverters and batteries. Yeah, we work in the Nordics, but we are heading into more markets hopefully soon. Yeah, our business is a lot about integrations, and on the one side, integrating and selling services to different stakeholders in the electricity system. And the main three in the European markets are the transmission system operators. They buy ancillary services, grid services. We also have the local grid companies, the DSOs, and they sometimes want to buy flexibility from batteries as well, local flexibility. And it's basically like a peak tariff on a city basis. They have a couple of hours every year where they have constraints in their grids, and then they need flexibility. And it's an alternative to build out expensive new grids as well. And the third main actor is the balance responsible parties. Every electricity retailer has one, and they are the one doing the actual trading with energy on the wholesale markets. So yeah, integrating to the buyers of flexibility, and on the other side, integrating towards the hardware, the inverters, the batteries, and we integrate to quite a few.
Yeah, well, you've covered a few kind of revenue opportunities there, just in the way you've described the way the business operates. Obviously, we're seeing more storage installed in the Nordics and particularly in Sweden. Can you, I believe you've got a slide that can tell us a bit more about the kind of main revenue opportunities that exist for C&I storage at the moment?
Yeah. Yeah, so Sweden has been a very hot market. I think the whole of Nordics has been, maybe not Norway. They have too much hydropower providing their flexibility. But in Sweden last year, I think it was around 1 gigawatt of build out of batteries. And the main kind of driver was to get access to the very high priced ancillary services. And the one that we mostly did was, it's called FCRD, FCRN, and that's a capacity market that is needed to avoid frequency disturbations. So if a nuclear power plant or a HVDC cable blacks out, then we need to have backup power that can react within seconds. So that's what most of our batteries have been doing for the most amount of hours last year. And if you did that, you earned around 200,000 euros per megawatt last year. So yeah, good payback on those batteries.
Yeah, absolutely. But we do see a kind of trend in markets when battery storage gets deployed, it comes in, there's these great frequency opportunities revenue-wise, but then as more batteries come in, that can obviously start to get a little saturated. And I'm just wondering what that does for you as a battery optimizer when it comes to the optimization of the C&I storage. Does that present challenges for you guys to find other routes outside of just maybe those initial frequency response services that are on offer?
Yeah, absolutely. That's exactly what has happened the last year. So during the first half of the year, prices for these kind of limited markets, I think they start getting saturated in the summer, and then they dropped. I think they halved in price every several months in a row. But what happened then in the fall was that a lot of other things started to get, I mean, not more profitable in an absolute sense, but in relative to the FCR market. So this graph shows this is only comparing different ancillary services, but there are different ancillary services that are more energy intensive. MFRR, AFRR started getting more profitable in the end of the year, and then energy arbitrage and also local flexibility that I talked about in the beginning with the grid companies. I think around 10% of our customers live in an area where the local grid owner buys this kind of flexibility. So the need of optimization has increased a lot, and it's become a lot more complex, and the batteries are doing a lot of more things at the moment, and we are pre-qualifying for a lot of different ancillary services.
Yeah, and you said there are parts of Sweden where this can happen at distribution network level, is that right? So the distribution flexibility, did I understand that correctly?
Yeah, exactly. So I have another slide on exactly that. So I live in Gothenburg on the west coast of Sweden, and we have two grid owners there who has started a local flex market, and they want to be able to connect more electricity intensive industry and a lot of EVs coming in. So they've started every winter to buy power from batteries during the coldest months of the year. So we in November we put all of our assets, residential, C&I, and utility assets into this market. So they've been remunerated both for the capacity and also during the specific hours where the DSO has needed this power. So you can see a graph here. It's a battery that until around 5 a.m. it's doing this FCRD ancillary services, and then it's charged a couple of hours, and then it's been activated during the hour where the DSO needs the power. So this, it's actually very few hours. So a lot of customers have peak tariffs in around Europe, but these peak tariffs basically you need to activate your battery, I mean, quite often. Whereas I think this is a lot smarter way moving forward for the European power system, where the DSO buys power only on the hours where there's an actual need in the grid. So this actually just happened 10 hours this winter where our batteries were activated. They said before the winter that they would need it around 50, maybe 100 hours, but then the winter was a bit warmer than expected. So in the end, it didn't happen that much. But we really believe in this area, and I think this is a very, I mean, the DSOs around Europe say that they want to put billions of euros into new grids, and I think this is a much cheaper and faster way to enable more consumers and production.
Yeah, and I assume, so as a CNI storage owner, right? I mean, this is not something I can do as an independent, right? If the aggregation is what's really giving you the tool here, right? How do you, what kind of bids and offers are you making there? How does that work? Do you just basically have a big network of your storage assets that you can then hand over to the DSO or the transmission operator and say, this is how much megawatts I've got. What do you need? When can I work it?
So it's all about optimization, and we see our role as first make these assets available to these income opportunities. So it's a lot of integrations and also contracts with the different stakeholders that I talked about. But then it's also the optimization part. So it's both kind of enabling batteries to be on these markets. But then in the end, I mean, we put these assets on this market because it was higher revenue than what they would have earned doing anything else, and it's very few hours, so it's very high kind of revenue per hour doing this. But then, I mean, I mostly talked about the kind of services that we sell from our customers. But we also do kind of behind the meter services as well when it makes sense. So batteries in our kind of virtual power plant also do electricity spot price arbitrage behind the meter. They also do solar self-consumption. So far in Sweden, these kind of behind the meter services has been a lot lower in revenue than these outside the meter selling these services. So that's why we've been mostly doing the kind of selling flexibility services, and for that you kind of need a VPP, because there are so many actors. There are thousands of DSOs. There are over 20 BRPs, and one TSO in every country. So
yeah, well, it certainly sounds at the moment like the frequency services. There's still a market there, but of course, there is also, as you say, that behind the meter service that we can do for spot price arbitrage too. Well, listen, we've still got quite a lot to get through today. Thank you very much, Eric. I'm sure there'll be some questions coming in the Q&A for you later as well. But from there, I think we'll also jump across and we can welcome today Smogovic from Enertech. I believe he is on the line also. Hi there. Today, you are going to, I believe, tell us a bit more about how Enertech has worked with GoodWe as well, and the kind of integration you've done with your energy management software.
Hi, thank you. I would like to thank you to PV Magazine and also to GoodWe that we can attend this great webinar today. I would like to present you some business cases and some integration of the GoodWe system with the energy management system. So, where are we coming from? Our headquarters is in Slovenia, Maribor, so close to the Austrian border. We are one of the leading company in the renewable energy sector in Slovenia, focused mainly on the residential and CNI sector. We are 16 years on the market right now, installed more than 25 megawatts of PVs up to today, and we have really wide and dedicated team of experts. Which are delivering top tier solar energy solutions, including PVs, battery storage, EV chargers, and energy management systems. So over 2 years, we are successfully partnership with GoodWe. We choose GoodWe because they could provide us a really technical, advanced, and reliable solutions up to today, and we are really happy to partnership also in the future. And we are for sure the largest implementer of the GoodWe systems in Slovenia. We implement more than 200 batteries up to today. And what is very important, we also successfully integrate the GoodWe systems with our own energy management systems. So for the glue, how are we working? So the first steps and very important steps is market demand, or the customer's demand that we want to research in the detail. Because according to this demand, we can then in the further steps, we can do simulation. We developed our own simulator to simulate and calculate savings and the return on the investments of the ROI. This is the very complex tool running on SQL servers and have millions of combinations to provide us the right solutions to the end customer. So this step is important because we can explain or show to the end customers what are the savings on the systems and when they will return the investment. So the third step is installation of the PV systems, battery storage, EV chargers, and energy management systems. And we do not do this step by ourselves. We collaborate with partners. Fourth step after that, again, very important, we connect those devices through the energy management controller to our own platform with the algorithms and then apply all the settings that energy users on the field will work in the way that we calculate in the step 2. And the last step is monitoring of the system and then maintaining and have the long-term reliability. So a little more about the energy management systems. The purpose is to optimization of the electricity production, electricity storage, and electricity consumption. We can connect various energy devices such as power plants, battery storage, EV chargers, heating pumps, and cooling units. We can do a real-time analytics and monitoring, and what is the most important, automation for the maximum savings. With the energy management system, we can do really a reduction of the electricity cost. We can achieve a lower dependence on the grid. We can avoid the peak loads. We can provide higher consumption efficiency. And in the end, of course, environmental impact and lower of carbon footprint. This is our control room where we have central platform where is connected all the devices on the fields, and colleagues, they monitor any issue, alarms and parameters if they are in the way that they should be. So in my second part of the presentation, two business cases. The first one is from the manufacturing company. So what was the challenge here? They have a really high peak power in the morning, so a high demand for the electricity and high demand for the power, because they start the production in the morning, they start a morning shift, and this result high demand for the electricity. So they have a high energy consumption during expensive tariffs period. I don't know for the whole country in Europe, but in Slovenia we have now five tariff periods system, and it's really important in which tariff block you are using electricity and what power of electricity do you need in a specific block. And the third challenge, they were already existing power plants, but it was really low direct compensation from the existing power plant. So what we've done, so the power plant was already there. We installed the battery storage, more than 300 kilowatt hours and more than 150 kilowatt of power. And we also installed energy management system for the smart control. Here you can see what we achieved. The blue line is the average profile of the company before our project installation, and magenta line shows us what we achieve and what kind of savings we achieve with this project. So we've done peak shaving, we've done direct compensation, and we've done load shifting from the higher to the lower tariff block. And those are the savings that we achieve with the systems. And I have to tell you that it is not only one algorithm that is working, because algorithm change from the working days to non-working days, from the summer to the winter, spring, autumn, and we adapt the systems according to the needs. So I think this one, the business case, is one of the important part of the every project. So the total investment was 277,000 euros. We obtained subsidies for the project in the high of 67,500 euros, and annual savings on almost 40,000 euros. So the return of the investment is approximately a bit more than 5 years, which I think is for the industrial company and a project like this a very short return on investment. And the second example is the commercial building. Here with a little bit different challenge. We have required power of the building for the 110 kilowatts, because mostly of the 10 charging stations that were required and the electrification of the fleet within the company. But the building had only 53 kilowatt of power capacity. So on the chart, you can see that with these requirements, we had a lack of almost 90,000 kilowatt hour of electricity annually. So what we've done, solar power plant, 160 kilowatt peak, battery storage system, 156 kilowatt hours, energy management systems, and 10 EV charging stations. So you can see here also the blue line was demand of electricity power and amount of the electricity. We've done with the battery and energy management system the peak shaving, and also influence a lot on direct compensation and achieve quite high annual savings. So here also the investment was 230,000 euros. Also, we obtained subsidies of a little more than 64,000 euros. Annual savings around 45,000 euros, and return on investments lower than 4 years, which we also think that is quite good for the commercial building. So in summary, we are 16 years in the renewable energy experience, and we work more than 2 years intensively with battery storage systems and energy management. Our primary partner is GoodWe. We have in-house simulation tool. We developed our own energy management system. I'm speaking about the algorithms. We used controllers. We buy controllers from the other supplier. And what we would like to tell also that we are really open to collaborate. We would like to collaborate with other partners around Europe who are also work with the GoodWe and need maybe the experience and the knowledge that we obtained in the past 2 years. So we are open to discuss and have collaboration potential.
Thank you. Thanks today. Great to have these insights from your projects there and working with GoodWe. Well, we do have one more presentation coming up soon this afternoon. That's from Barbara Terinia, who's talking about GoodWe's BIPV solution, Building Integrated Solution. First, though, time for a little Q&A, I think, on the commercial storage side. So I would now like to invite our speakers so far to turn your cameras back on. And we have a couple of questions from the audience. And listeners, please do keep your questions coming in. You're a little bit quiet today, so please, please keep questions coming in. We do have a bit more time. First of all, quite a few people, quite a few listeners are asking kind of about the market situation surrounding these projects. Can you, and I think probably it makes sense to ask this question to Thanasis first of all, can you say how common is it for CNI customers to be earning revenue from frequency regulation with their batteries, and what is the impact of this on project cost?
I'm not sure if I understand for which topic of this of the CNI. Are you talking about the arbitrage? Are you talking about the peak saving? I mean, can you be a little bit more specific, Mark?
I think from frequency regulation, specifically, the person in the audience was asking.
Okay. We see already in some regions in Europe as a pilot project, the grid owner offers benefit to the companies that they can support to the stabilization of the grid to be around in the 50 hertz. And in some cases, we have bigger devices in the past, like they were calling them synchronous condenser, that they were trying to stabilize the grid. But today, with the storage system, we have the capability to do this job completely spread around all over the country, all over the region. The idea behind is to give a special price list to the owner of such a system, a special price list given by the grid operator, in order to be able to evaluate if it makes sense for the owner of the system to sell or not, to take or not energy for the battery in order to stabilize the system. It's I wouldn't say it's in a pilot level, but somehow it's on the way to be applied all over Europe, this one. And the more renewable we see connected in the grid, the more often we see the problem of the stabilization of the grid. So, long story short, it's something that it comes here to stay as an extra tool for the investors, I would say, equal the owners of the system.
Okay. Anyone else have anything to add on this question about C&I batteries kind of participating in the market?
Yeah, I think from my side, just to point out something, in the past, we've seen that the grid operator really pretty much they were the owner of the infrastructure, the generation infrastructure. But now in here, we're seeing a shift in towards having, rather than infrastructure, it will be kind of infrastructure as a service. The grid operator doesn't have to own any more assets. He has only to contract them. And by relying on the third-party owners of the battery, for example, and through the aggregation, what Eric has also explained us, they can achieve pretty much exactly the same without performing those huge investments on large plants. And from the operator and the owner, point of view, you have a revenue stacking. You are using your PV or battery for your own use, and that extra capacity reserved for this kind of services, you utilize it as another income, reducing this way the return of investment. So from my point of view, it's a win-win for every single market player.
And well, Thanasis, you mentioned just now that this is kind of rolling out all over Europe. We've talked quite a bit today. We've kind of focused a bit more on Nordic markets. Do you see a similar situation sort of across the continent? Sorry, I think you're muted, Thanasis. We can't hear you.
I'm sorry. I was mute. I follow the rules. You know, we said when we don't speak, we have to be mute. So,
of course, yeah.
Anyway, yes, I think we have to accept that Europe is one market. No matter if we are so many countries with so many languages and so many different people, in the energy sector, we are one country. And whatever is happening today in Germany, we see tomorrow in Greece. And accordingly, everywhere we see the same model, the same scheme, the same applications. Already we are interconnected, all of us, like one family. So yes, clearly the answer, Mark, is that we see this trade to be applied all over Europe, sooner or later.
Okay. So sooner or later, maybe other markets need to have some catching up to do, but.
And we need to think about a future-proof equipment. If we install something now, we need to be sure that it's ready to offer services to the grid operator that they don't need them now, but the equipment has to be capable to offer the service tomorrow. And this is something that at the end of the day, we save money. The customers save money. And we have big experience now. We see that today the grid operator is asking things that 2 years ago they were completely out of the discussions. And now investors, they need to go back to get a special equipment, to be more flexible, to offer more services, etc., etc. So thinking ahead, it's always a benefit for everybody, for all the parties. Absolutely. And Faisal, I think this question probably comes to you first of all.
Another fairly popular topic with the audience is the cooling systems. Can you talk a bit about how is there a difference in power consumption between water and liquid cooling? Also on the round trip efficiency of the whole system.
Yeah, certainly there is a difference. For the air cooling system, the consumption is lower than for the liquid cooling system. But we are talking about lower, we are talking about 10 to 15% range. So we are not talking a huge difference. For sure, the investment on the equipment for the liquid cooling versus the air cooling, it's much higher. So the battery for the same, if we had to put the same kilowatt hour capacity, a liquid cooled battery will be more expensive than air liquid cooling. But on the other hand, liquid cooling offer you another advantages, which is a better cooling system. And a better cooling system should live for a long life cycle of the battery. So it will last long. If you had 1 megawatt hour storage battery with air cooling system, it will probably last 20-30% less than the cooling system. But it's true that with the liquid cooling system, this is a technology that is fairly new to the industry. So we cannot say that the industry has implemented the gigawatts of these sort of things. So the final result, as in every technology that comes to the market, whether it's in storage or in the aviation and aerospace or any other industry, and it's time to be proven. But the industry is pushing this way, and we are convinced that for large application solutions, the liquid cooling system it will be a better solution than the air-cooled system.
All right, thanks, Faisal. Nice, clear answer there. Well, I think we could sit and talk, of course, all day about CNI storage, but we do have one more presentation to get through this afternoon, and that comes from GoodWe's Barbara Torini. Barbara, are you with us?
Hello.
Thanks for joining. Welcome, and please go ahead. All yours.
Thank you. Yes, the focus of my presentation today is on the solar potential of low-bearing roofs and how GoodWe replied with a dedicated product. Before I start, by the way, I would like to point out that this opening picture you see here has been used also from my colleagues, as it is the very new GoodWe headquarters in Suzhou. I wanted just to spend a couple of words about it. It is an impressive ultra-low energy building equipped by the full variety of our products. And every detail has been screened and designed to meet the lowest energy consumption. So at the end, it came out that about 30% of the building's energy needs are covered by the production of our PV products. Firstly, we are going to talk about the role of buildings in Europe's energy consumption. As surprising it may seem, buildings are the single largest energy consumers in Europe and are responsible for a significant portion of total energy use. In fact, they surpass even the transportation and industrial sectors. This makes buildings a top priority for the European Union. Reducing energy consumption in building is critical, not just for lowering emissions, but also for cutting costs and enhancing sustainability across the continent. Therefore, it is important to recognize that improving energy efficiency in our buildings will be one of the key steps toward achieving a greener, more energy-conscious Europe. Let's take a closer look at the structure of many buildings in the European Union. Here in this slide, you see that even 50% of European buildings constructed since 1970 have flat roofs. While flat roofs might seem practical, they often come with significant challenge of their low load bearing capacity. These make it difficult to install standard photovoltaic solar panels without significant structural adjustments. And it is clear that it is important to develop solutions that enable us to retrofit these roofs with solar panels without compromising structural integrity. That's exactly why we as GoodWe, we developed Galaxy. So I come here to the Galaxy product. It is our lightweight solution designed to meet this specific need. The challenge with most lightweight solutions lies in their reliance on polymer and plastic, which often lack long-term reliability. In contrast, this module uses 1.6 millimeter thick glass at the front of the panels. Despite this, the specific weight of the module is only 5.6 kilograms per square meter, making it incredibly lightweight. Reliability is then the core of our approach for the PV building material sector. And we also work closely with other departments to ensure seamless integration with inverter and storage system. So in the following slide, we explore the key benefits of using glass and the installation methods that ensure proper ventilation for optimal performance. So here, in accordance with the relevant ISC international standards, we conducted a series of rigorous tests of the Galaxy series, including the hail test, hotspot tests, and mechanical load test. I report here that Galaxy passed all of these tests with excellent performance. And here you can see a comparison of the results after simulating a hailstorm, so after the hail test. So the hailstorm diameter tested was 25 millimeter with a speed of 23 meters per second. On the left side, we have the result of a standard polymer product that are currently on the market, which show glass breakages and cell damages. And on the right side, you can see Galaxy, which shows almost no degradation at all. This demonstrates the superior durability and reliability of Galaxy in challenging conditions. So, moreover, modules with polymer surface are also subject to deformation, which can lead to material damage and dirt accumulation over time. In contrast, the Galaxy modules remain rigid and firm because of the glass on the front side, and allowing water to flow freely across the surface, creating a natural self-cleaning effect. Furthermore, the glass front panels of Galaxy offer excellent UV blocking properties, especially when compared to polymer surfaces. This also helps significantly reduce long-term degradation, ensuring the durability of the modules. Moreover, commercial flexible modules often have exposed junction boxes and cables, which under the action of water, weather, and sunlight age and degrade quickly. To protect these components, they typically need to be covered with metal parts, which add additional material costs and result in longer installation times. In contrast with the Galaxy, there is no need to expose the electrical connections. They are placed between the module and the roof surface with sufficient distance to prevent any direct contact and offer greater protection and reduce installation complexity. The rising temperature topic can significantly impact the efficiency of the products. That's why we don't just offer individual modules, but a comprehensive fixing solution, which includes adhesive clamps and ventilation strips. Ventilation plays a critical role in ensuring optimal module efficiency, especially when it is set parallel to the roof. To verify this, we carried out temperature tests and we evaluated the product performance, both with and without ventilation pads. The test data shows that the backsheet temperature decreases as the height of the ventilation strip increases, and the best compromise between rear ventilation and material cost was calculated to be achieved at about 40 millimeter height. That's why the distance pads we provide from GoodWe, together with our module, are set at 40 millimeter, which ensure both effective temperature regulation and prevents direct contact between the junction boxes, the cables, and the roof surface. For metal roofs, the fixing is also possible, and we also deliver our components, can be secured with clamps positioned along the ribs. It is important to note that whether the metal roof is galvanized or coated, it doesn't affect the performance of our components. The next generation of Galaxy modules will go even further in meeting customer needs by enabling easier installation on monolayer membranes, as we have said, PVC, TPO, or bitumen. The new Galaxy 440 watt, featuring N-type TopCon technology, will be available with spacer bars that are already attached to the module as an option. As you see here, for every module, there are 6 bars on the rear sides that are already installed from us. And this innovation is estimated to cut installation time by half, making the process faster and more efficient. Now I will present a concrete example of how Galaxy has been applied in a recent project in Australia. GoodWe provided a smart BIPV solution to Alspec. Of course, as I say, BIPV, I know it is indeed meant as integrated photovoltaic. In this case, it is more applied photovoltaic, but Galaxy is just one of the various products that we have in our portfolio, and they are all based on application on buildings and integration in buildings. Alspec is a leading aluminum processing company based in New South Wales. And the project involved the supply and installation of a 100 kilowatt solar system on the roof of their headquarters and manufacturing facility. Alspec's operation heavily rely on electricity for aluminum alloy process and resulting in high production costs. Moreover, in response to a recent 30% hike in electricity prices introduced by the government, Alspec sought alternative energy sources. Solar photovoltaic technology emerged as the ideal solution, but the low load-bearing capacity of the new roof prevented the installation of traditional solar panels, both due to their weight and also for the drilling required for the installation. This created potential risk related to structural integrity and leakage. In light of Alspec's concerns, GoodWe Galaxy series solar panels provided to be the perfect solution. Alspec selected the GoodWe Galaxy series 315 panels to ensure a seamless and leak-free installation. This was coupled with the GoodWe's efficient AT string inverters and the Lynx F storage. The Galaxy series optimizes both energy generation and self-consumption. The entire system is designed to cover 80% of Alspec's electricity needs for production and operations. Now I think there should be a video about this project if we still have time.
All right. Well, thanks a lot, Barbara, for sharing these insights on this nice lightweight module with us. We are just about running out of time, but I will squeeze in a couple more questions on this solution. So, Barbara, I think you mentioned that you're using a TOPCon cell in this module. Can you say any more about the kind of performance and efficiency, power rating of the module?
The module has about 21.4% efficiency, which is a very good result indeed. And yeah, so with the benefits of the TOPCon technology and type cells technology in comparison to the older technology, which is with PERC cells, that are not only the efficiency, but for example, the better performance by low light behaviors.
Yeah, and in this sort of lightweight modules for non-load bearing rooftops, in this segment you tend to see a lot of thin film technologies. Can you say how does this solution compare to one of the common CAD-TEL or maybe CIGS solutions that you might find on the market?
Well, the modules are, of course, we are not providing, as a GoodWe is providing a lot of products also for the energy production, and Galaxy is, as I said before, it is just one of the variety of the products that you can see, by the way, behind me, and all the modules are switching to the new N-type TOPCon technology. And according to the specific roles of the modules, for example, we have also the bifacial modules for carports, and in which we have also very high bifacial factor. And regarding Galaxy, the main difference that we see here is not only that it is a product that provides the benefit of the low light. The low weight, which is 5.6 kilogram per square meter, but nevertheless, what very different is this front glass of which provides the stability and the durability of the product.
And how does the performance of this Galaxy module, how would that compare to kind of a standard system that obviously is heavier, but
the performance due to the technology, to the TOPCon technology, are almost the same. And as I said before, we have seen that the modules that are completely and directly glued on the membranes of the roofs, as usually happens in the case of lightweight products, give higher losses in the systems. But we provided with this measurement that we made, and with this distance had obtained with these distance bars, we calculated that the losses are the same as a parallel system, as standard modules mounted on rails.
And it appears that what you have here, this is a frameless module design.
Yes, exactly.
Is the gluing important there, because it can be quite difficult to clamp, can't it, without a frame?
Yes, it is frameless. It has no frame, or better to say no metal frame, but it has a kind of reinforcement in TPO material among the edge of the modules. So that provides additional durability and stability of the product. And nevertheless, it provides also the drawing of the water on the surface of the module.
Okay, well, thanks very much, Barbara. We have gone a little bit over our time already, so I think we will have to leave it there. Thank you once more to all at GoodWe, all of our speakers for today as well, and well, over to Matthew.
Yes, thanks, Mark. And of course, thanks again to Faisal, Thanasis, Barbara, Eric, and today, and to GoodWe for partnering with us in today's webinar. And of course, to our audience, we had some great questions there. I'm sorry we couldn't get through them all, but I'm sure you learned a lot today. Just some last pieces of housekeeping as a thank you to attending. We are offering a 10% magazine discount on subscriptions. You just use the code webinars10 to get your 10% off there. We also have some updates there, some various science studies online, most read online in PV Magazine, from tilt angles to water generating electrical charge. It's well worth checking out. And of course, we have some more webinars coming up as well. There is more to come from PV Magazine. And the Thursday, the 20th of March, we have Navigating Quality Risks for US Module Buyers, from warehouse modules to new factories. And on the 3rd of April, we also have one for our Italian-speaking audience members on agrivoltaics. Italy, of course, a leading market in that field. So once more, thank you very much for joining. And if you could do a favor to PV Magazine, please do complete our audience survey. We really appreciate your feedback. So once more, I've been Matthew Linus, also joined by Mark, and thank you for joining today.